A point source of heat of power P is placed at the center of a spherical shell of mean radius R. Because it's a shell, okay? So it has a very thin structure at the surface. So if the inner radius is R1 and outer radius is R2, so in this case, the difference is so small that we take a mean radius known as R. Obviously, it is R1 plus R2 divided by R, but we take the mean radius as R only, okay? Now, or you can also say the thickness of the material. Thickness, see, this is the thickness D, can be written as R2 minus R1. That is the thickness of the metal part over the material part. Now, as we know, power, which is dq by dt, it is I've just calculated in the previous question. For a sphere, it is 4 pi k R1 R2 T1 minus T2, that is upon R2 minus R1, temperature difference. Now, here R1 is almost equal to R2. As I told you, it's a shell, so R1 almost equal to R2, so I can write R square. T1 minus T2 is given as T only, okay? T, temperature difference is T only. So we have written that, and R2 minus R1 is the thickness D, and that is what they are asking. Then the thickness of shell should not be less than. That is what they are asking. Okay. Okay. I did not read the question properly. I started explaining the diagram. Let me read the question again. The material of shell has thermal conductivity K. If temperature difference between outer and inner surface of shell is not to exceed T, okay, then the thickness of the shell should not be less than. So they are asking thickness of shell. From here we calculate thickness of shell. D is equals to 4 pi R square T divided by P, and that's the answer to the question.